queries per second with UDP and 4,000 with TCP. Paul Bixby thinks I'm wrong, thinks there must be something wrong with my tests, and that's okay. You know, the quote goes, being wrong just means the world is more interesting than you thought it was. But even with a significant penalty, super chasing over HTTP should be a, if all else fails, get me this information approach that we need. And so we're actually going to go ahead and start running a DNS over HTTP endpoint on the internet within the next couple of weeks so that the libraries that are out there, if all else fails, can always get stuff resolved. Because that's the only way we're going to get to 100%. Wrapping. So I talked about chasing, I've talked about tracing, I've talked about chasing, tracing, packing. This is wrapping. And wrapping is an idea of this crazy Kiwi by the name of Brett Watson. And what Brett said to me is, you have to be willing to separate the content of DNS from the transport of DNS. Now this was a fairly profound point, and it led to an interesting concept. If you look at X509, X509 certificates always contain hi. This is a certificate for www.foo.com, foo.com that's signed by VeriSign or Thought or GoDaddy or whoever. So there's a chain back from where you are all the way up to some trusted certificate authority. X509 can also contain the DNSSEC chain. SSL's already moving X509, so we do DNS over X509 over SSL. You know what totally passes through hotel mini boxes? SSL. Also, we get really high performance because it's delivered inline without any kind of external query having to happen. Now, to implement this, what you have to do is you have to do just like super chase. You have to extract all of the keys necessary in order to resolve a zone. And then you have to shove it into an X509 certificate and validate it during the actual certificate validation. Now this would have been a lot of work for me. So Adam Langley at Google may very well have sent me a private, unofficial build of Chrome. Yes. That is getting HTTPS. It's got the lock. But when you look inside, that certificate has a DNSSEC chain enabled, full DNSSEC inside of Chrome. What's up? So I want to be clear, this was private, this was unofficial, this does not at all represent a commitment by Google to DNSSEC, DKI, or X509 certificate embedding. This is just Adam and I seeing what was possible. So with that, I think it's a good idea to start talking about actual applications. Where do we implement DKI? What I showed you at the beginning of this talk was SSH, specifically FreeShell, a federated identity system for OpenSSH. It's based on the idea that end nodes should authorize and validate identities and not public keys. You are not P times Q. You are at least an email address. Today, the way that this works on the server is you go to the authorized keys file and you provide a list of email addresses that are allowed to log in. When someone tries to log in, they have a special syntax that they use for their username. That syntax is parsed, and if the declared user is actually someone who could potentially log in on that account, then DNSSEC is queried securely end-to-end to say, all right, Dan at remotesupport.org wants in. Dan at remotesupport.org, if he had the right private key on his system, yeah, we'd let him in. Let's go to DNS to find out what public key to validate. So that's what it is today. Tomorrow it's going to be an actual LDAP backend, sort of like this Fed SSH package out there. And you'll be able to say, let everyone in the support.vendor.com group log into the machines at somecustomer.org. This is going to be very, very nice. Now I'd like to go a little bit philosophical into why this is a big deal. People have been selling what's called federation for years. Federation being the ability to authenticate users outside of your organization. All of the stuff has been terrible. The reason why is we have a couple of choices. Our first choice is end-to-end complexity. That means every company that wants to authenticate someone else has to make a deal with every other company who wants to authenticate someone else. It is end-to-end complexity that gives us things like On Gmail, if you receive mail from eBay or PayPal, then you get special user interface. Why was it one email provider and two possible senders? Because the management load of getting more done was too high. Then there's the problem of risk of the kingmaker. You always have a situation where one group says, all of you, why don't you just trust us? Everyone trusts us, and we declare who is who. It's great and it's wonderful, and it turns whoever is in that position of the centrally trusted person into a monster. It happens every time. And so the final approach, and this is what we see in the existing certificate authority system, is key bleed. No one wants there to be a God, so you end up with everybody's God. It's not any better. What is interesting with DNSSEC is that the DNS root is run by ICANN. And for all the controversy of ICANN, this is a group that is massively constrained. They are constrained by a technology that delegates as soon as possible. They are constrained by politics of the worldwide nature that you cannot imagine. ICANN getting things done is a tremendous amount of work. That is not a bug, that is a feature. That means you have a neutral overseer. Net neutrality began with ICANN, of all places. It's kind of crazy. So what do you end up with? DKI gives us federation that actually works, because you have the trusted root that the technology needs, but you have the controlled root, the managed root, the governed root that the politics require. So what do? Are we going to go ahead and manually hack in LDNS or libunbound into each package one by one by one? Well, you know, maybe that might be useful for some things. It's definitely a way to get the best application integration. But you know, Linux and Unix, everything's using OpenSSL. Specifically, the OpenSSL call x509_verify_cert. This is a nice and self-contained library call. What could we possibly do with that? So, another thing we're releasing is called Freeload. Freeload adds DNSSEC transparently to existing applications. If it validates a certificate, we will make it validate a certificate successfully using DNSSEC. There is some prior work. libval shim from Russ Mundy at Sparta will actually go ahead, and it also transparently applies itself to applications, but it does so at the DNS layer. It makes sure that applications get the right IP address. That's nice. There's a million ways to attack IP. I'm sorry, that's just how it is. The other thing that Russ Mundy's code does is it assumes that if you're validating for www.foo.com, obviously you have the foo.com certificate, because when this code was written, the root wasn't signed. With Freeload, Freeload is operating at a different layer. It's saying, look, let's take the software out there that is actually trying to be secure. It's actually trying to make an encrypted end-to-end safe link. Let's take its validation layer, which already has handlers for errors if validation fails. Let's take the validation layer and replace or augment it with the authentication layer of DNSSEC. So for example, you ever gone ahead and used these command line web tools and said curl some address, and you get back, this big error, and the last line, of course, is, if you'd like to turn off curl's verification of the certificate, use the -K or -- insecure option. Now think about what this means. At some point they said the -K option, and people missed it. So they have 2 points in the documentation where they say, here's how you turn off the security. That is a system that has failed. Now we're going to go ahead, we're going to LD preload freeload.so, and bam, this is a story all about how my life got twisted upside down. Works glorious. If we go ahead and we turn on debugging, we say export DNSSEC debug equals 1. What we see is a lookup happened to what we call the deliberately incorrect schema. We look up sslalabsolute.www.hospitallink.org. It has returned this hash 5E0905B and so on, and that is actually the correct hash of the certificate seen at that address, and validation occurs just fine. So that's all that's happening. You have this silly little value in DNS. It's wrong. We're working on the right way to do it. If you go ahead and you change the value, you make the hash incorrect, poof, curl doesn't work anymore. It's not enough for it to do a DNSSEC resolution. The hashes have to match. We set the information back. We go ahead and we can use curl. We can use wget. The same code, the same configuration works for all the protocols. Now, all OpenSSL apps means all OpenSSL apps. So you've got Postfix as a mail server set up, Postgres as a database, MySQL as a database, Apache. Now, why would it be interesting to alter certificate validation in Apache, which is a web server? We've had the capability in web browsers to do client certificate validation, meaning it's not just the server that has a cert, the client has a cert. But today, really getting a certificate issued by one site or a smart card issued by one company to work anywhere else, yeah, good luck with that. With DNSSEC, it's trivial. You get a smart card, we get a request, it claims to be an email address, you go ahead and find out, so what's the public key associated with this user? And the group that issued the smart card is the group that hosts the public key, and now that public key works on every server on the globe. Works like a charm. Welcome to domain key infrastructure. But I'd like to go ahead and stay focused on browsers. OpenSSL is great, but browsers don't use it. Internet Explorer uses a crypto API, and Firefox and Chrome use NSS. Also, there is no LD preload on Windows. There's just no way to go ahead and hack an API in Windows. So what are you going to do? HTTPS proxying. This is kind of neat, actually. I had no idea this was there. PDP Ignusid this and put out this thing called httpservers.py. It's based on the work of Azuki Hsiao, Andres Riancho, and Dave Vitale. And basically, the web browser has, since the beginning, had what's called the SSL proxy or secure proxy. And what that does is, it says every time an SSL connection is attempted to be made, please do connect www.site.com:443. Now, this is actually very nice. I mean, this is a channel by which I can see what the browser wants without having to push any code in there. I should really build a proxy. So we built a proxy. It's called Foxy. It is a remote validation proxy for production browsers. Basically what you do is you provide the browser a custom root certificate. So the browser knows, okay, you know, I'm going to trust whatever this random piece of code tells me. When the connect line comes in, we know the domain the browser is expecting to authenticate to. It's pre-declared to us. So we basically gin up a certificate at that point. We allow the connection to come in, and then we hook it up to an SSL connection of our own out to the internet. Now here's the thing. We are not actually going to certificate validate the cert out there. So we don't want to make these connections unless they're good. We're outsourcing certificate validation. We're not disabling it entirely. However, since we're outsourcing certificate validation to OpenSSL, and OpenSSL is running Freeload, we inherit DNSSEC for nothing. And just so you see what this means, there's the browser lock from DNSSEC in Internet Explorer. There's the browser lock in Firefox from DNSSEC. There's the browser lock in Chrome. No private build. It just works. Done. Move on. Now here's a neat trick. This is a bad idea of old style. There's something very interesting we can do once we've outsourced validation. It doesn't involve DNSSEC, barely even involves DNS. Wouldn't it be nice if we could bootstrap trust only with a domain name? What if we put the hash in the URL? Yeah, that's not a good idea, but it is actually something that works. So basically what we have here is HTTPS SSL hash bighash.www.pba.org. If you can go ahead, you can actually even extend this to, you can put a hash in front of an IP address, and the server will say, well, I connected to that IP, here is the hash of that IP, I will let it through. There are lots of reasons why this is bad, but if you really, really need to bootstrap something and you don't have any other way of declaring what certificate